Hey class, welcome back. This is going to be our second to last class of the school year here. We're going to continue with solving these quadratic equations using inverse operations. So just like we've been doing the last 7-8 weeks here, right? Print out these notes so you can follow along, print out a blank copy of these notes. And if you're not able to print these out, again, right, get out that sheet of paper and write these example problems as I do them. And as always, right, reference my notes afterwards when you're doing the homework if you need to, so you can see the steps as well. All right. I will be having a Google conference today, Thursday, right, from 10:30 to 11. If you can make it, if you have questions, right, bring your questions there. And I'll do the same thing on Friday as well. All you have to do is go to Schoology and click on the conferences link, and I'll be there, kind of a drop in. If you have questions or anything, I can help you out. All right. And if not, that's fine, right? Just watch this video and follow along and do the homework. And if you don't have any questions, and great. And if not, then you can, drop in for that Schoology conference. All right. So again, just to kind of talk about the steps again for solving quadratic equations using inverse operations, otherwise known as the square roots, right? We want to isolate that quadratic term, all right? So yesterday, our quadratic term kind of looked, or I'm sorry, on Tuesday, kind of looked like just this, right? It was just an x squared. Well, today, you're going to notice our quadratic equations are going to kind of be with parentheses, all right? So it's going to be x plus some number or x minus some number squared, all right? So this is going to be our quadratic term today, right? This is what it's going to look like. It's going to be inside a set of parentheses, right? And again, we know it's a quadratic term because of that little 2, right? The little exponent of 2 is what makes it a quadratic. All right, whether x is by itself with that squared, or if it's a quantity, right, inside of parentheses being squared, that is also a quadratic term. All right, so to isolate it, right, we're going to use this idea of inverse operations, right? So adding and subtracting are inverse operations, just like multiplying and dividing. Right, those are inverse operations. All right, and then we're going to take the square root of both sides of the equation, right? That's going to be our next step here. And we're not going to forget about that plus or minus sign, right? Because when we take the square root to solve, we're going to have two solutions, right? A positive side and a negative side, right? That's where you put those two signs. All right, and to kind of go along with these lines of inverse operations, a square root is the inverse operation of a square, a little exponent. All right, that is also an inverse operation. All right, so after we take the square root of both sides and we get that plus and minus sign, we're going to simplify that radical expression and make two equations if needed to finish solving. All right, sometimes we're going to have to make two separate equations and solve both of them to get our final solution. All right, because again, these are quadratic equations, so we're going to get two solutions here. All right. And to simplify those radical expressions, right, that's going to be using these numbers here, right, these perfect square numbers. All right, so right, square root of 4 is 2, right? The square root of 3 is 9. The square root of 16 is 4. The square root of 25 is 5, right? And so on and so forth, right? So these are your perfect square numbers because when we take the square root of them, they come out into whole even numbers. All right, 21 and 12. All right, so here we go. All right, so we're going to solve the following equations using inverse operations. All right, so example 1, we have x minus 2 squared is equal to 100. All right, so here, this is my quadratic term here, right? This whole thing of x minus 2 squared is my quadratic term. All right, so it is isolated, right? There's nothing outside of those parentheses on this side of the equation. So now I'm ready to move on to step 2, which tells me to take the square root of both sides. All right, again, this square root undoes this square. So on my left side here, I'm left with x minus 2 is equal. Well, now it's a square root of 100. Well, here we go, right? That square root of 100, that is a perfect square. So that's 10. And because I took the square root, right, don't forget your plus or minus. All right, so now I'm at x minus 2 equals plus or minus 10. So now this is where I have to make two equations, right? My first equation is going to be x minus 2 is equal to 10. And my second equation is going to be x minus 2 is equal to negative 10. All right, now I'm going to solve both, right? But I solve these the same exact way, right? By adding 2, add 2. So we get x is equal to 12, right? 10 plus 2 is 12. So that's one of my solutions. And I'm going to solve this equation the same exact way by adding 2, except now I have a negative 10 plus 2, and that gives me a negative 8. All right, again, because we're dealing with negatives, you probably want to use a calculator just to be safe, right? So make sure you have those calculators out as well when you're doing these problems. All right, here we go. Example 2, we have the quantity of x plus 6 squared is equal to 25. Well, again, right, we have our quadratic term is already isolated, right? Because this is my quadratic term in the parentheses here. So now I'm ready to take the square root of both sides, right? My square root will undo my square. So I'm left with x plus 6 on my left side equals, all right, I'm not going to forget my plus or minus. And the square root of 25, again, is a perfect square number. And that just turns out to be 5. All right, so now I'm ready to branch off and make my two equations. All right, so now I can say that x plus 6 is equal to positive 5, or x plus 6 is equal to negative 5. All right, and now I'm ready to solve both of these the same way, right, by subtracting 6 to both sides here. And we get x is equal to 5 minus 6 is negative 1. And here I subtract 6, I subtract 6. And we get x is equal to, here we have a negative 5 minus 6 more is going to be a negative 11. So those are my two solutions for example number 2. All right, so now for examples 3 and 4, right, these look very similar. All right, both of these are not, my quadratic term are not isolated because there's a number out in front of my parentheses. So to isolate my quadratic expression, I need to divide by 3 first. And when we do the one side, right, we must do to the other. So I'm going to divide by 3 first to undo this 3 times my quadratic term here. So now I'm left with x minus 6 squared, right? It's still in parentheses and it's still being squared because all I did so far was divide by 3 so that I can isolate my quadratic expression. Now it's isolated, right? Now I'm ready to take the square root of my left side and I take the square root of my right side. Again, this square root will undo my square, so now I'm left with x minus 6 on my left side equals plus or minus, well, the square root of 9 happens to be just 3, right? And you'll kind of notice with today's lesson as well as the homework that my radical expression is going to end up being a perfect square. All right, so it's just x minus 6 is equal to plus or minus 3. And now I'm ready to make my two equations, right? X minus 6 is equal to positive 3, and x minus 6 is equal to negative 3. All right, and I solve these the same way, right? I'm going to add 6 to both sides. And we get x is equal to 3 plus 6 is 9. All right, and same thing here. I add 6 to both sides here. And we get x is equal to a negative 3 plus 6 is going to give me a positive 3. So here are my two solutions, right? 9 and 3, or x is equal to 9 and x is equal to 3. All right, so now why don't we pause the video and you guys do number 4, work it out just like I did on example 3, and let me know what you get for your two solutions. All right, let's see how we did here. Right, so first things first is divide by 2 to both sides, right? And that's going to isolate my quadratic term. So now I get x plus 3 squared is equal to 98 divided by 2 is 49. All right, now I'm ready to take the square root of my left side. I take the square root of my right side. All right, again, I do that to isolate my quadratic, or sorry, to get the x plus 3 all by itself, right? Because the square root will undo the square. So now you got x plus 3 is equal to plus or minus, and the square root of 49 is just 7. right? So now we make our two equations of x plus 3 is equal to 7, and x plus 3 is equal to negative 7. And now I solve both of these the same way, right? By subtracting 3, and we get x is equal to 7 minus 3 is 4 as one of my solutions. And then minus 3, and my second solution is going to be x is equal to a negative 10, right? Negative 3 minus 7 more is negative 10. So hopefully you got those as your two solutions, or at least one of them. So great job if you did. And again, if you didn't, that's okay, right? We're going to do more practice here. All right, we got two more to do here. All right, so in example 5, you have the quantity of x minus 5 squared plus 7 is equal to 88. All right, so here is my quadratic term, all right, my quadratic expression, and it looks like it's being added by 7. So to isolate it, I need to subtract 7. All right, so now I'm going to bring down my quadratic expression here of x minus 5 squared is equal to about 88 minus 7 gives me 81. All right, now what is my next step here in solving? All right, that's it. I take the square root to both sides. And my square root will get rid of my square. So I get x minus 5 is equal to plus or minus, and the square root of 81 will give me 9. Now, what is my next step here? That's right, I want to make two equations, right? We get x minus 5 is equal to 9, and we get x minus 5 is equal to negative 9. And now to solve this, we add 5 to both sides, and we get x is equal to 9 plus 5 gives me 14. And again, I add 5 to both sides on this equation, except this time I have negative 9 plus 5, and that'll give me a negative 4. So those are my two solutions. All right, we got our last problem here. Right, example 6, we have the quantity of x plus 7 squared minus 4 is equal to 60. All right, so for this one, what is our first step in solving this quadratic equation? That's right, we have to isolate the variable by adding 4 to both sides. So here we're going to get x plus 7 squared is equal to 64. Now I'm ready to take the square root of my left side. I take the square root of my right side. All right, again, I do that to get rid of my square, and now I'm left with x plus 7 is equal to plus or minus the 8, right? Because the square root of 64 is just 8. All right, now I'm ready to finish solving by making my two equations. All right, so what are my two equations that I need to make now? That's right, we get x plus 7 is equal to 8, and we get x plus 7 is equal to negative 8. All right, so now I'm ready to finish solving this by subtracting 7 to both sides. All right, so we get x is equal to 8 minus 7 is 1. That's one of my solutions. Right, I'm going to subtract 7 to this side as well. But here we get a negative 8 minus 7 more is a negative 15. So my two solutions are x is equal to 1 and x is equal to negative 15. All right, hopefully these notes made sense. Again, if you have any questions, please reach out. You guys are ready to try the practice homework assignment. You can find it on Schoology and just use Cami or upload and scan it when you're done. Nice job. And we have one more class after this. Oh, and I also forgot to mention that we have this workout example down here, kind of with a step-by-step example, all right? So use this also to kind of reference when you're doing the homework or if you have any questions, right? You can see the steps here of isolating the square term first, taking the square root of each side, right? And don't forget the plus or minus sign, and then writing those two equations, one with the plus and one with the minus, and then you solve both.